if you're given the zeros, these directions say write it in standard form with the given zeros. In order to write it in standard form, what form do you first have to write it in? Factored form. So if minus 5 is a 0, what parenthesis does it come from? If minus 5 is a 0, what does it come from? Plus 5. If 1 is a 0, what does it come from? So that's factored form. To then change it into standard form. What's the only difference between factored form and standard form? Yeah, no parentheses. So what process do we have to go through? Foiling. You can only FOIL 2 together at a time. So x times x, x times 5, 5 times x, 5 times 5. When you FOIL, you can only go 2 at a time. And what FOILing really means is just each part in the first multiplies with each part in the second. So to finish this out, what does the x squared first multiply with? The x. So what's x squared times x? What does the x squared multiply with next? Negative 1 to give you negative x squared. Is there anything left for that x squared to multiply with?
No.
No. What's the next number that multiplies?
10x.
So what's 10x times x?
10x.
10x times minus 1. Is there anything for that 10x to multiply with? No. What's the next number that multiplies in? That's the grunt work. The rest of it is just writing it in standard form. Standard form means highest exponent down to the constant. So what's our highest exponent? X cubed. And then what would go next? Yeah, so when you take minus x squared plus 10x squared plus 9x squared. And now your x's, so it's negative 10 plus 25.
15.
And then our constant. So that is the equation in standard form. So standard form is really just practicing FOIling. Standard form, the first part of your blue packet asks you to write something in standard form. That just means if it's not, rewrite it so it goes highest exponent to lowest exponent. And then to classify it, if you have to classify this one, if it has a degree of 3, so its highest exponent is 3, what word means exponent 3? Cubic. How many pieces does this have? 4. Is there a special word for 4? No, so it's just a cubic polynomial. Hello.
Yesterday's
Homework. Yeah, it's a good question. Nope. I just need to stand here. I feel like I brought that back. I probably didn't though. Yesterday's homework? Oh, he's right. I'm wrong. Tell him sorry. But not like too sorry. Each day we are going to spend, just do one review question. So flip your half sheet over to the back side, or if you've already turned it in, just grab a slip of paper, find a little bit of free space, and we're going to do one practice sketch. So from that, would you please sketch it? So what's its degree, leading coefficient, and behavior, turns, zeros. Leading coefficient, Caleb. So then those two together, McKenna, what's our end behavior? So where does it start? Perfect. Turns, at most, how many turns can we take, Katie? The degree is not 3.
Yeah.
I was like, what?
Yeah. Okay. So 8. So 8 is the most.
And then how do you get the other ones?
Subtract 2, so 6, 4, 2.
Alright, so since this is in factored form, it's not the highest exponent, what do? Add them all up. The zeros, JR, where's our first zero at?
0.
And what does it do there? Maddie C, where's our next one at? What does it do? Levy, where's our next one at?
1.
And what does it do? Lizzie, where's our last one at? And what does it do? Perfect. When you sketch, what goes down first? Your zeros. And then look at your end behavior. When I start drawing this, where does my pencil start? High or low? High. When I hit -3, what do? Bounce. When I hit 0, what do? When I hit 1, what do? When I hit 5, what do? Final thing, count. How many turns did this guy take? 6. Go back and circle it. So each day we'll do a review problem like this. How do the rows all fit together? What does the graph look like? This is a sketch. If we wanted to make it into a graph, what would be the only difference? Would it be more accurate? Yes.
Okay, so I have a question.
Yep.
So if it's like in the very front, if it's like -3x squared, would you have like a +3 for
Nope.
0?
Nope, it would just, that -3 would just tell you your leading coefficient is negative.
Okay,
It wouldn't
so
change
it doesn't-
anything.
Like it's not even in the zeros or anything.
Correct. It would just change it if you were to make a graph. When you punch it into your calculator, you would just start with the -3 there. So if you were to graph it, you would plug in just to see how high these pieces go. That's really it. In your notes, so we are going back to our factoring foldable because now every way that we will factor in Algebra 2 is in this foldable. So you have just one reference that if you're asked to factor something, you can go back to one thing to look at it. Quick review, you don't need to write these down. What does it mean to factor by GCF? Greatest common factor, so you look for, yeah, biggest thing that you can take out. If you had a trinomial with a is bigger than 1, the only difference is, what would that parenthesis have to start with? Not x and x, but 3x and x. So that affects it. Difference of two perfect squares. If you had 16x squared minus 49. So difference, two perfect squares.
4x.
Good. So remember, if there's no middle and you're subtracting two perfect squares, 16 comes from 4x and 4x. Whenever you multiply to a negative, you have opposite signs. 49 comes from 7 and 7. So that's what makes the middle go away. These are the main ways we factored before. We are just throwing in a fourth and fifth way. So go to grouping. We're going to do the grouping one first. And grouping is unique in the sense of this is the only one that uses 4 terms. So if you have something that's 4 pieces long, you have to factor it by grouping. That's the only option we have. Everything else is for trinomials or binomials. If you have something that's 4 pieces long, that's how you know grouping is probably the way to do it. What grouping is it's really just super fancy greatest common factor. So looking at this in kind of different ways, between 3x plus 5x, what's the greatest common factor of those? X. What would be left on the inside? So when you take out an x, what's left behind, you divide. If it was something like this, like 4 triangle box plus 3 circle box. So the whole thing about a greatest common factor is you look for what you can take out. It could be a number, it could be a variable, it could be something completely different. You're just looking for what they have in common. So between these two parts, what do they have in common? The box. So I'm going to take out the box, and what's left of 4 triangle box? And then what's left of this one? 3 circle. So when you take something out, you can take out anything that they have in common. What grouping is you're not necessarily taking out a number or a variable, you're taking out a whole chunk. You're taking out an expression. We'll do 3 examples like this. First one is right there. Factor by grouping has to work, has to be our option. It's 4 pieces long. There's no greatest common factor between all of those, like 1, 2, 9, 18. Can't take anything out. Can't take anything out of the x's. So factor by grouping is the only thing that could work. Factor by grouping means just look at it in groups. So just looking at the first group, what can you take out of x cubed minus 2x squared? X squared. So I'm just looking at the first group and I'm taking out a greatest common factor. What's left of x cubed? What's left of minus 2x squared? So that's the first group. Do the same thing, but look at the second group. You guys know that when you factor, if you start with a negative, do you leave the negative or take it out? Take it out. So what can you take out of negative 9x and 18? Negative 9. So what's left of negative 9x? 18 divided by negative 9? Negative 2. So by just looking at it in 2 groups, do you see how those 2 parentheses are the same? What this is saying, and I'm going to write this, this is kind of off to the side. This is saying x squared times box minus 9 times box. The box just happens to be an expression, but those are both x minus 2's. So I'm just swapping it out, substitution. What do they have in common? The box. Do you see how it's on both of them? So I'm going to take out the box. What's left of x squared if I take out this piece? Yeah, what's left of the other one? What does the box equal? So what we're doing is we're doing a greatest common factor again, and we're saying it has this expression and that expression in common. So I'm going to take that in front, and then what's left is x squared minus 9. So when you take something out, you're not taking out 2 of them, you're just taking out x minus 2 from both. So it's not x minus 2 squared, I took out 1 set of those. Can you break down x minus 2 anymore? Can you break down x squared minus 9?
Yeah.
What?
X minus 3.
X minus 3 and x. Yeah. So factor by grouping is really just doing greatest common factor 3 times. First part, second part, part in the end. Now we'll do this one. Looking at the first 2, what do they have in common? What can we take out? X squared. So what's left on the inside? Y squared minus 3. There are no like terms because this is x squared, y squared, and that's just a y squared. So yeah, that's a good point. There's nothing that can be combined here. Everything's different. Now look at the next 2. What can you take out?
Negative 4.
Negative 4. So then what's left on the inside?
Minus 3.
Whenever you factor by grouping, those parentheses should be the same. Because the whole thing about factor by grouping is now they have something in common. What do both of those have in common? So I'm going to take out y squared minus 3. So I'm taking that out, taking that out. So what's left of this if I take out that parenthesis? So I mean, it's great if you guys can look at this and understand, like, oh, I'm factoring out a y squared minus 3. It's another greatest common factor. But if you're looking at this, like, what is she doing? There's a pattern. One of your parentheses is always going to be what's in your parentheses. The other parenthesis is what's outside your parentheses. So when you factor by grouping, one parenthesis is what was inside the parentheses, the other parenthesis is what was outside the parentheses. So it's just inside, outside. So yeah, think of it as you're taking it out, but in reality, it's inside parentheses, outside parentheses. Can you break down y squared minus 3 anymore? No, 3 is not a perfect square. Can you break down x squared minus 4 anymore?
Yep.
Yep, to what?
X plus 2.
Yep, x plus 2, x minus 2. So factor by grouping is just a pattern. There's one of your parentheses. There's your other one. Yes.
How do you get the x plus 2 and x minus 2?
Because if it's x squared minus 4, where does x squared come from? X and x. 4 is a perfect square, 2 and 2. So since there's another pattern there, this one we can't do because it's 3 a perfect square. No. All right, one more. Looking at the first two, is there something we can take out? No. Looking at the second two, is there something we can take out? No. When you have all adding, does it matter what order you add in? No. So you can rewrite this. So if I start with bx squared, which other guy should be with bx squared? Ax squared. So you are allowed to rewrite this so that things just go in an order that makes your life easy. So since it's all adding, you can rearrange it, because now grouping-wise, you can do grouping, because what can you take out of bx squared and ax squared? What's left? What can you take out of 2a and 2b? Is it a positive 2 or a negative 2? Positive, so put plus 2, and then what's left? Are your parentheses the same? Yeah, a plus b is the same thing as b plus a. So as soon as you have that, you know that this is going to factor into one of your parentheses is what's inside your parentheses. So what's inside the parentheses? A plus b. Your other one is what's outside the parentheses. So what's outside the parentheses? Can you break down x squared plus 2 anymore? Nope. If it's a plus sign, automatically can't do. So one of these is just what was inside the parentheses. Other one is what was outside. So factor by grouping. If you have 4 pieces, you should factor by grouping. The last really new thing we're going to go through today is perfect cubes. So go to the perfect cubes page. If you don't have a perfect cube page, just find an open space somewhere or go to the back side. Glue in that little formula, the little sheet that you grabbed. Take a second, glue that in. Yes. See if you can peel it off. That's the nice thing about glue sticks. You can usually unpeel it.
It's also a bad thing. It can't peel off.
What?
It's also bad because it can't peel off.
Well, only if you like really try. We are going to go through how to factor perfect cubes. So the perfect squares are 1, 4, 9, 16, 25.
36, 49.
So it's everything squared. So we're going to go through the perfect cubes. So cube means what exponent? A 3. In your notes, you need to make this list because that'll save you a lot of time. The perfect cubes aren't as easy. What is 1 cubed? 1. 2 cubed. 8, because 2 times 2 is 4, times 2 is 8. 3 cubed. 4 cubed. 5 cubed. 6 cubed. Oh, Maddie's got it. Maddie. 216. And is this list ever going to end?
Nope.
No. So what we're looking at is, what if you have 2 things that are perfect cubes, how do they factor? They factor through a very special formula, and all we're going to do is plug into that formula. So the formula, I'm not going to show you where it comes from. I'm just telling you it will always factor in this way. So the way you read this formula is if you have a cubed minus b cubed. So if you have a perfect cube minus a perfect cube, it'll factor into this formula. If you have it plus, it'll factor into this one. The only thing that gets kind of hard about this is finding your a and your b. Because if you look at this, this is saying a cubed. So it's not the whole number, it's where it comes from. So a and b are not the numbers you see, it's whatever cubed gets you that number. So if we have x cubed plus 27, step 1 is find your a value and find your b value. So a is where the first thing comes from. So what to the third power is x cubed? X. B is wherever the 27 came from. So what to the third power is 27? 3. If you look at your list, 27, oh, it came from a 3. So you know your a and your b, and there's 2 formulas here, one for adding, one for subtracting. Since we're adding, do we use the top one or the bottom one? Bottom. So you just plug into the right-hand side. So the left-hand side is telling you this is what you're given. It breaks up into this. So it's parenthesis a value plus your b value, parenthesis a squared, so x squared, minus a times b, plus b squared. What's our b squared? 9. That x squared minus 3x plus 9, can that be broken down anymore? Can you multiply to 9 and add to 3? No. So you can never factor that other part down anymore. So you're just done as soon as you plug in. Jumping down to this one now. The x cubed, if something cubed is going to give it away that you're supposed to use this formula. If you look at that list, it's 250 and 2 on there. No. But your first step, whenever you guys want to factor, is to look for a greatest common factor. What's the greatest common factor? 2. So take a 2 out. What's 250 divided by 2? 2 divided by 2? 1. So by taking that 2 out, now do you see a 125 and a 1 in there?
Yes.
Good. Label your A and your B. So A is where that piece comes from. So where would 125 come from? 5. Where would x cubed come from? X. Where would 125x cubed come from? 5x. So if you have a number and a variable, just take them piece by piece. Where does a 1 come from? 1. 1 cubed is 1. And then just decide, are you going to use that top equation or the bottom one? Bottom. You're adding. So the 2 hangs out. And then it starts out as your A value, plus or minus, plus your B value. And then what does it say next? A squared. This is always the one that catches people. It's your whole A value squared. So it's saying 5x squared which is not 5x squared, 25x squared. So when it says a squared, if there's a number and a variable, they both get the squared. And then is it plus or minus? Minus a times b, so 5x times 1, plus b squared, what's 1 squared? 1. Again, this second part is never going to be able to be factored, so you're just done right there. So once you know a and b, it's just plugging into the formula. Last one we will do. When you factor, there are different ways of factoring, kind of like reducing. So if you have 3, 6, if you reduce it to 2 over 4, is it reduced? Does 3, 6, can you reduce it to 2 over 4? Like, are they the same? 3, 6, 2, 4? Yeah, they're both 1/2. Is it better to write 2 over 4 or 1/2? 1/2. You always want to reduce it all the way. So when you look at this, even though 8 and 64 are both on that list, first thing you should always look for is the greatest common factor. So is there a number that goes into 8 and 64? 8. So still take out greatest common factors first. 64 divided by 8? 8. Because if you don't take out that 8, it's like you're not reducing your fraction. So take out a greatest common factor first. Label your a and your b. So what's our a value going to be here? M. And then if it's an 8, what's your b value? It's just 2. Because this minus just tells you what formula did you plug into. So you're going to use the top one or the bottom one? Top. So it starts with an 8 in front. And then it's a minus b. So minus 2. And then a squared. What's our a squared? Plus ab, which is 2m, plus b squared, which is 4. You'll never be able to factor this one any further, so you're just done right there. So if you have perfect cubes, it's just plugging into a formula. Questions on the perfect cubes? Go to the extra examples and copy down these 4 quickly. These are for real, the last 4. Parentheses. If you split up an x to the 4th, what do both of your parentheses have to start with? X squared. So the first one is just x squared, x squared. And if it's a minus 9, what does it have to be? Can you break down a 3 anymore? Is 3 a perfect square? No, so you're just done. On b, what can you take out? How would you factor b? You can take out a 2x squared. What's left of 8x to the 4th if you take out 2x squared?
8x.
Nope. 4x squared. Can you break that down anymore? What's 4x squared?
2x.
What's 9? 3. If you're subtracting, can you do this? Yeah. So x to the 4th just means when you split it up, x squared, x squared. The C one, this one looks goofy, but if you think of it in the normal way, usually it's an x squared and an x right there. How many times does x go into x squared? Twice. How many times does x squared go into x to the 4th? Twice. So as long as that relationship that your middle goes into your front 2 times, you can just factor this like normal. Only difference is where does x squared come, or x to the 4th come from? X squared and x squared. If you have a minus sign at the end, what are your signs going to be? Different. And then we want to multiply to 24, add to 5. So what multiplies to 24 and can get you a 5 with opposite signs. 8 and 3. 8 times 3 is 24, and then 8 minus 3 is 5. If we want to end up at a positive 5, where should the 8 go? Yeah. Can you break this one down anymore, the first one? If it's a plus sign, can you ever? No. This one, can you break it down? No. 3 is not a perfect square, so you're just done right there. On the last one, to factor, what would you do first?
2x squared.
You can go simpler.
2.
2. If you take out a 2, then what's 2x to the 4th? 16x squared is now just 8x squared. 12 at the end. So taking out the 2, now what do your parentheses start with? Plus sign at the end. What do you know about your signs? They're the same. Look to the middle. What are they? Multiply to 12 add to 8. Can you break that down anymore? No, they're both plus signs. They're not perfect squares. Done. So on your assignment today, have your notes out. You can do the cubes without those formulas, and you probably don't have those formulas memorized, so just keep your notes out.
I need to. Like, I forget like what's happening. I really just like to record.
You guys have over 15 minutes, which means don't pack up early. Use your time. I know it seems like there's a lot of homework out right now, but if you still have a lot of homework you have to get done, it's because last week you probably didn't do what you were supposed to do. Because you should have 2 worksheets that you had almost the entire period on Thursday to work on. Half a worksheet from Friday, which you have almost the entire period to work on. Yesterday was new with the blue packet. That was all review, and you weren't doing that whole thing. So make sure you check in classroom for the blue packet. And then this. So if you are behind from last week still, yeah, it probably seems like you have a lot of homework. So get yourself caught up. For the retakes on the quadratics test, I put it in classroom, but if you didn't see it, sometime this week you need to come in before or after school, and we'll go through your test, see what you did wrong, and then I'll give you some practice problems. Another time then, after that, you need to come in and do the actual retake. So 2 times, once for help, once to do the retake outside of class if you're going to retake it. Retakes have to be done by next Tuesday. After next Tuesday, you can't retake that test anymore, so that gives you a week to find some time to come in. The actual going through it with me doesn't take long because I'll probably take like 4 minutes to go through your test, see what you did wrong, do a couple examples so you can see like, oh, that's all you needed to do, and then I'll give you the practice worksheet. Once you're done with that, come in for the retake. So if you're going to retake the last test, that is the process. 1 week to do that. Okay. And I feel like I kept on telling you guys your quiz is next Tuesday. It's not. It's next Wednesday. So we have lessons all this week, and then Monday, Tuesday review, quiz on Wednesday. I feel like I kept on saying Tuesday, but that was a lie. That's it. Have fun.